Can epigallocin gallate and antioxidants crisis?
Our category is microbiology. I'm Adeline Lay.
And I'm Susan Hamacreen.
Our project aims to uncover natural alternatives to antibiotics to address the rising issue of antibiotic resistance. By exploring solutions that function under oxidative stress condition, which will be the hydrogen peroxide in this experiment, we hope to enhance treatment options for infections.
We have 4 different scenarios. Group 1 was the addition of E. coli K12 colony with no additives, EGCG or hydrogen peroxide. Group 2 included the colony with the addition of 1 milliliters of EGCG but no hydrogen peroxide. Group 3 had an E. coli K12 colony with 0.5 milliliters of hydrogen peroxide but no EGCG. And Group 4 contained a colony with 1 milliliters of EGCG and 0.5 milliliters of hydrogen peroxide. Once these groups were done with incubating at 37 degrees Celsius for 24 hours, we used a colony counter and observed the behavior of how the bacteria was affected.
Epigallocatechin gallate, known as EGCG, is an antioxidant found in green tea, and it helps reduce inflammation, aids weight loss, and prevents conditions like heart disease.
Escherichia coli K12 bacteria, also known as E. coli K12, belongs to the taxonomic family.
We measure 15 grams of EGCG in a cup and 100 milliliters of cold water in a beaker for dilution. We then use sterile pipettes and loupes to prevent cross-contamination and spread the bacteria around for even distribution.
Major issues were forgetting to add water to the bacteria in the first group, which required redoing groups 1 and 2, and removing hydrogen peroxide in the second experiment since it eliminated all of its bacteria.
We learned about the interactions between the bacteria and the EGCG abstract, specifically how the antioxidant properties of green tea can suppress bacteria compared to hydrogen peroxide.
We tested the activity of bacteria with oxidative stress and how an antioxidant could contribute to the process of reducing bacterial growth. Testing compared to the real world by its proper incubation and colony counting, which is similar to researchers and labs, and the tests were completed and done at school with supervision.
According to the data table in trials 1 through 3, Group 1 had a mean of 34.33 colonies, Group 2 had a mean of 5.33 colonies, and Group 3 and 4 had a mean of 0 colonies. And according to the results, Groups 3 and 4, hydrogen peroxide was too strong, and it resulted in the bacteria being eliminated. However, with the antioxidant alone in Group 2, it demonstrated a decrease in bacterial growth compared to Group 1.
The experiment's results support the hypothesis, showing that E. coli K12 growth was significantly suppressed in the presence of both EGCG and hydrogen peroxide. The strong effect of hydrogen peroxide inhibited the antioxidant, reducing effectiveness of EGCG against the bacteria. Data indicated a significant difference between group 1 and 2, confirming that the variables impacted bacterial colonies. To improve the procedure, incorporating more variations of EGCG and hydrogen peroxide concentrations could reveal differences in bacterial colony counts and damage levels. Additionally, shortening incubation period from 24 to 8 hours could yield more consistent data as it minimizes ingredient degradation and captures the immediate effect of hydrogen peroxide and EGCG on E. coli K12.